Hello everyone and welcome back again. This is going to be another do and don't, so we'll call it Do's and Don'ts of Calculus. Sorry about that. dadoc, episode 2. And this is going to talk about factored versus standard form. Now, like in episode 1, we talked about rational exponents and how it was better to not deal with a root of a variable. We didn't want to deal with the square root of x. We wanted to deal with x to the 1/2 power because it's going to be so much easier. Same thing is if you have like x plus 2 times x plus 3, this is one of the don'ts. Now, you can get your zeros from this, you can get a lot of information from it, but once we start getting into differentiation, you're going to want to deal with this in a certain form. So we want to use our algebra skills, and we want to multiply this out. Now, if you want to FOIL, you can FOIL. I use a box method because I use this kind of both ways as far as multiplication and factoring. I put my factors in rows and columns, multiply to get into the boxes. X times x, x squared, 3x, 2x, and that's a 6. So I'll get x squared plus 5x plus 6. Now, this guy, when we're talking about derivatives, especially derivatives, this is easier to work with. Whoops. Seeing too much of easier spelling with the Z's. We don't want that. This is easier than factored form. Oh, I can't spell today. But that's okay. Now, it'll be painfully obvious once we get to a derivative that this guy is going to be easier to deal with than this, because, like I said before in episode 1, the product rule for differentiation is tougher than the power rule, which we can apply the power rule multiple times to this and actually get a derivative in 2 steps, and this is going to be a lot more algebra that you have to deal with. Will you get there? Absolutely. Do you have to get there doing that? No, this one's easier. So, easier for calculus, more difficult for calculus. But remember though, factored form has its positives. You can find zeros, you can find all sorts of stuff. We're still going to have to use this form, but you have to be able to transform it to this form, especially when the step that you want to work on is going to that step is going to require either a heck of a lot more work to do this way than this way. So get used to multiplying stuff out, get used to factoring it, because you're going to have to work both ways on this. It all depends on what you're trying to do. But this guy for differentiation is a whole lot easier than that guy. So that's pretty much it for this. This one's pretty short. So more to come.